Hello, my name is Hoy and I represent Group 11 of Design Technology class. For our final project, we'll be making a smart battery bin. We do realize that for the Fulbright residents, people consume a lot of batteries. However, because there are no bins whatsoever to dispose them, they do not know the correct procedures to dispose their batteries. In addition, even if they know the correct methods to dispose their batteries, the fact that they have to put the batteries into the bin without receiving any fund properties leads them to actually have no motivation to put the bins into the right place. Therefore, we would like to create a smart battery bin to make this disposal process much easier and more comfortable. In this video, we're going to show you our prototype, the things that we changed during our process of creating this bin, some reflections, and finally some upcoming plans for the future. So now, let us see the prototype. So as you can see here, this is our prototype. It is not that perfect. You can see some imperfections around here or around here. We have not managed to cut them perfectly. We have created an initial sketch here. That was actually our initial sketch. However, we made a lot of modifications. We realized that the volume of the batteries were too small, so we widened the dimensions. However, that is just one modification we made to the original plan. The key important aspect to realize here in our modification is that our orientations have changed. This is not a fun bin, this is a smart bin. We first wanted to make it eye-catching, and as one person dropped the battery, they would receive a candy and there would be light and music. However, that required too many mechanisms and skills, and it does not really solve the convenience problem. So we prioritized the main functions. Let's have a look. So the first function we have here is the ultrasonic function. So as I move my battery around 50 centimeters away from the bin, the ultrasonic sensor would open its lid for me to put the battery in. It would slide down and meet the battery box. After it meets the battery box, it actually triggers the second mechanism, which is the load cell. So as the battery falls into the box, it actually triggers the load cell and the value of the weight will be incremented. As the weight gets bigger and bigger and eventually reaches a point, the load cell would actually trigger an LED light, which is around here. It would trigger it and say that it is the right time for us to dispose our batteries. So how do we dispose our batteries? We figured that the process would be very, very mechanical if we just open it and take it by ourselves. So therefore, we created a cupboard mechanism. You would just slide this thing out and collect the batteries by yourself using gloves. So for some other changes, let's have a look at the surface. So we would actually place a mica piece right here. The reason for that is because we would like people to actually see the process of the battery running down into the box, which actually is a fun factor itself. The surface is the next change. Instead of having thick wood, we would actually use very narrow wood, which is only about 5 millimeters in width. We want it to be sustainable rather than convenient. Thus, the materials are quite heavy and thick. The 5 millimeter wood plate and mica would actually solve the situation. It would make it easier to move and carry, but it is more sustainable to use. The positioning of materials is also another noticeable change. Instead of having electronics at the bigger part of the portion and having to push and pull the wires through the barrier, which is the one you see right here, we confidently put them into one small piece, you see is this area, and connect them to both the weight sensor, which is around here, we're going to connect it down here, and the ultrasonic sensor, which ultimately is around here. So to sum up, what have we changed? Our major changes come from the orientation. We make this thing a smart box, not a fun box. We also change our mechanisms. We have the ultrasonic sensor as well as the weight sensor. We also have the changes in positioning. And finally, we have the changes with regards to the fun factor, which is the surfaces of Mica, where people could see the processes. So at the end of the day, we prioritized functionality over fun. We abandon the overthinking of placing a candy or showing different lights on top of our battery bin to favor the more constructive mechanisms. Next, we prioritize the sustainability over the strict materials so that we can actually make our product very flexible and we can easily design them into our real product. And finally, we customize our space so that it is large, so that we can store a large amount of batteries and make our battery bin look more visually pleasing. So after finishing all of these processes, we're heading towards the future. What are we going to do in the future? We're going to do three things. Our first stage is that we're going to assemble the mainframe and finish the connecting Arduino and electronics. We're going to use AutoCAD for our 2D drawings. We're going to use our CNC cutting machines to cut our wedges as well as our 5mm Mica pieces. We're going to use small hand tools to assemble the components, and we're going to finish connecting the Arduino and the electrics to form the basic functionalities. We plan to finish these by April the 29th. Afterwards, it's our second stage, which we're going to assemble the Arduino and electric parts into the machine, as well as test its functionality, whether it performs its functions or whether it's broken. We plan to finish this by May the 9th. And for the final stage, we're going to beta test the product, meaning that we're going to give our product to the users and see whether they can use it or not. We're also going to write precautions and steps to use our product for the users. And for the final step, we're going to launch the product. So for this third stage, we plan to finish this by May the 22nd, thereby finishing the entire process. So to make all these possible, our group has managed to work with each other very well, despite the difficulties of the project itself and of the members' lives. We managed to stay on track and finish our prototype with half of the time to go. With the final product right in our grasp, we figured that we would get our product done on time. Our group work was very productive, as we were able to finish our products without having to meet too frequently. When people had issues relating to their mental health or physical health, we sympathized with them and got them back on track. While noticing that this is a hindrance to our project's procession, we embraced them to facilitate the members with the best experience while continuing the processes. In the following stage, with the reassembly of the entire group, we are confident that with the cooperative working environment we have created, we will work with each other efficiently as a team, finish the hard work with precision and according to plan, and finish the final product. So at this stage, we will summarize what we have told you. So last term, we empathized, defined, ideated, and came up with this battery bin idea. Then we made our first sketchings, which is right there. However, as we built our prototype, we realized that there were some problems relating to the space, the positioning, as well as the mechanisms that we need to include in this battery bin, which is why we had to recustomize and form this second prototype, which considers the two mechanisms, the drawer function, and the unique positioning, which customizes the flow of the battery.
During the process of making this happen, we realized some constraints, time and skills. In terms of time, we were only given 2 months to finish our product, and therefore 1 month to finalize our prototype to start our real product. We realized that we had to make full use of this time in order to perform an operation regarding buying materials, assembling parts of prototype, and so on. We had to put a lot of things beside our priority, given our insufficient time. For instance, we had to put aside some potential fun factors, which had complex mechanisms of operating and the task of decoration to focus on assembling and basic functioning of the product. With limited time, it is crucial that we make the most out of it and make a satisfactory product, not necessarily a perfect one. In terms of skills, we realize that our group members have not had experience creating products from scratch. Our ability were limited in the sense that we had to connect what we learned from lectures about using small hand tools, CNC cuts, or printing machine to practice. Our confidence level were not high, which either mean that we waste more time to figure out how to use these tools, or could not incorporate to use of some into our process. This hinders the production of our designs, but we try to improve upon our skill every day and make the product possible.